So when we talk about factoring polynomials, there are a couple of different things that we have to do. One is you have to be able to factor a quadratic. And hopefully you guys can already do that. Factor a quadratic. You have to understand the remainder theorem that we just did. And we'll put that together with the integral zero theorem to make the factor theorem. So the factor theorem says that x minus a is a factor of a polynomial in x, p of x, if and only if p of a equals 0. So if you think about the remainder theorem, remember x minus a, if you're dividing by x minus a, p of a gives you the remainder. Well, if the remainder is 0, then it means that that binomial was a factor. And then, which makes sense, right? A factor is something that divides in evenly. So if there's no remainder, then it's a factor. So if p of a equals 0, then x minus a is a factor. That's the factor theorem. The integral zero theorem says the integral factors of the constant term of a polynomial are potential zeros of the polynomial. In this example here, what's the constant term? 3. So possible potential zeros, which is the a value, are factors of 3. That's what the integral zero theorem says. So it says the integral zero theorem is useful in factoring polynomials because it helps us find the zeros, which in turn gives us the factors. What we want to do is find a zero of this polynomial. So find a number that when we fill it in, gives us 0 as the remainder. And those numbers that we're going to try are factors of 3. So what are the factors of 3? Right, positive and negative 1, positive and negative 3. So those are our potential zeros. Potential zeros are positive and negative 1, positive and negative 3, because those are factors of the constant term. So we're going to test and find out which one actually is a 0. Which one do you want to test? I usually test 1 and negative 1 first, just because it's easier. And sometimes I even do it in my head. But if we're going to test 1, p of 1 is equal to 2 times 1 cubed minus 5 times 1 squared minus 4 times 1 plus 3, which is equal to 2 minus 5 minus 4 plus 3, which is equal to negative 4. What does that tell you based on this factor theorem? That it's not a factor. That x minus 1 is not a factor of that polynomial. So we'll test negative 1. So this is negative 2 minus 5 plus 4 plus 3, which is equal to 0. What does that tell you? It is a factor. It tells you that negative 1 is a 0 of the polynomial, which means that x minus negative 1 is a factor. So therefore, x minus negative 1, or x plus 1, is a factor. I don't have to check for other factors. I'm going to show you on the next slide what we're going to do now. We only need to find one factor. So there we found one. That's the factor theorem. As soon as you find one that equals out to 0 when you fill it in, then you found a factor. What we're going to do with that factor theorem is then factor a polynomial. So I'm going to give you a minute to finish copying this down if you need to, and then I'm going to show you how to factor a full polynomial. So here's the question that we need to be able to answer. Factor that polynomial. Is that the same one that we started with? That's the same one, right? Okay. So we already know one factor. Which factor do we know? X plus 1. We want to divide that polynomial by x plus 1. So to do that, I'll take negative 1 on the outside. Right, we're going to divide that by x plus 1. So synthetic division. Negative 1 on the outside. Divide. And then on the inside, the coefficients, 2, negative 5, negative 4, and 3. Bring down that 2. Multiply. Negative 2. Add. Negative 7. Multiply. Add. Get 3 multiplied, negative 3, and your remainder is 0. Good, that's what we needed, right? We knew it was going to be 0 because we chose a factor that we already found out on the last screen was a factor. That's how we knew to use x plus 1 because we used the factor theorem already and found one factor. So now what we have for this p of x, we have p of x is equal to 2x squared minus 7x plus 3 multiplied by x plus 1 because we already found that factor. Now we divide it by that factor, we have this new polynomial multiplied by x plus 1. Is it fully factored? No? Probably not. But how do we factor now? We have two choices, right? We could take that new polynomial, the 2x squared minus 7x plus 3, look at the potential zeros, use the factor theorem, and divide. But because it's a quadratic, we don't have to do that whole process. We can just factor, because you already know how to factor a quadratic. So I'm going to take 2x squared minus 7x plus 3 and factor that. It's going to be 2x. And x, and 3, and 1. You may or may not be able to do that factoring without using decomposition. But really, hopefully, you will get to the point where you can just do that. The way I kind of reason it out, the first term needs to be 2x squared. So it has to be 2x times x. The last term has to be 3, so it's either going to be 1 and 3 or 3 and 1. But I want 7, so I'm just kind of, I know I need to get a kind of a bigger number, so I have to do 2 times 3 to get 6. And then the 1, they both have to be negative because there's a negative in the middle and a positive at the end. Reasoning it out like that is the best way to do factoring because it's faster. But if you have to do decomposition, that's okay too. So I need to bring that one other factor down, the x plus 1. That's the fully factored form of that polynomial. A couple of different ways that we could check our answer. I'm not going to actually do it because I already know that that's the answer. But you can expand. When you expand, you have to choose two of the binomials, multiply them out using the distributive property, and then that answer by the other binomial. You can also check your answer by graphing. If you were to graph this polynomial, where would the zeros of it be? Do you know? 3, negative 1, and 1/2. Positive 1/2. 1 divided by 2. So you could check it that way as well, and we'll talk more about that graphing aspect later. But if you're doing some work and you want to check, that's how you could check. Here's one more. It just says factor. It's cubic, so we can't just factor using decomposition or some other method. So we need to use the factor theorem. What are our potential zeros here? Potential zeros, positive and negative 1, positive and negative 2. And we get those from the constant term of the polynomial. So because it has a plus 2 at the end, positive and negative 1, positive and negative 2 are the factors of 2. So then we test those to see which one actually is a 0. If I do 1, it's going to be 1 cubed minus 3 times 1 plus 2, which is equal to? 0. Yay, 0. We found it right away. So the 0 is 1, which means the factor is x minus 1. So we can say, therefore, x minus 1 is a factor. And so we're going to divide that polynomial by x minus 1. And I'm going to do synthetic division. Coefficients for synthetic division are 1, 0, negative 3, and 2. Watch for those zeros when you're doing the synthetic division. There's a 0 because there's no x squared term in there, but we still need to hold the place value when we're dividing. So bring down the 1. 1 times 1 is 1. 0 plus 1 is 1. 1 times 1 is 1. Negative 3 plus 1 is negative 2. 1 times negative 2 is negative 2. Remainder 0. I know that's fast, but you can take your time later and have a look at it. What we have then is that p of x is equal to the factor that we found, x minus 1, multiplied by what we get when we do the division, which is x squared plus x minus 2. If you did that synthetic division and got a remainder that was not 0, you'd know you had a mistake somewhere, right? Either you chose the wrong factor or you made a mistake with the synthetic division. So there are spots where you can kind of check on your way through. If you do the synthetic division and you get a remainder, you need to go back and look at what you did. Don't just keep moving forward. Now, can I factor that? X squared plus x minus 2. It'll have to be x and x, 1 and 2, negative and positive. And then I'm just going to check x squared plus 2x minus x minus 2. Yep, that works. So that's what p of x factors to. This is actually equal to x minus 1 squared times x plus 2, which is a better way really to write the answer. That factor, that x minus 1 is there twice, so do x minus 1 squared times x plus 2. That's a better way to write your answer.